Good morning, everybody. Welcome to day 2 of the Declarative. It's Friday. I hope you all had some coffee and you're ready for our talks this morning. I have some announcements before we start. Everybody should have one of these on their seat. You're either sitting on it or you picked it off of your seat. It's a feedback form. You'll hear a lot about this today. We do want to hear from you, so please fill in your feedback form. There is a small change to the schedule today. It's actually a misprint. Do you have your schedule handy? I will tell you what it is and show you how you can mark it so you don't forget. If you have your schedule handy, you'll see in the third column, at the very bottom, there's an OTR that's marked for being in room 1. It's not actually in room 1. It's actually in the banquet hall. Time is the same, the topic is the same, but the location is different. So if you plan to go to the OTR on, I can read it because it's too dark on the stage. Learning data science. Yeah, don't go to room 1, go to the banquet hall. You can make a little arrow to remind yourself, point it to that big blank space in the banquet hall, and then you'll have it right. Sorry about that. If you were here yesterday, you probably already know this, but you can pay food vendors with ATM, or you can use food tokens, but you cannot use cash or cards. If you brought cash or cards, please go buy food tokens. Today from 1:45 to 2:30, we have an OTR on failure stories in machine learning. Now this is a place for you to tell all the screw-ups that you had. It's going to be led by Vargava, coffee this morning, and it will be not recorded. It's an OTR. Our OTRs are not recorded, so you can speak candidly and freely. Our merchandise counter is open in the lobby from 11:30. And today there will also be flash talks like there were yesterday. We didn't have very many yesterday. Love to see some more people submitting flash talks. These are 5-minute talks featuring your new stuff, your ideas, your tips and tricks, but please no advertising packages. If you want to submit a talk, please see Harshal down there. Give him your name, your phone number, and the topic of your talk. Those will be happening at 5:40 in the banquet hall. And I think that's all of the announcements for now. There's also a diversity talk this afternoon, but I'll tell you more about that later. So, I'm kind of excited about this first talk. I'm not really a data scientist, I'm more an artist, so data visualization is something that bridges that gap. Can you imagine, like, creating beautiful data visualizations with Markdown? You know, like, /blink. You can. And it's Amit Kapoor, the founding partner of Narrative is going to walk us through how this works.
Hello. Hi, good morning, everyone. How is everyone doing? Fresh? All excited? We're going to have a lot of data visualization talks in the start. I'm going to just kick off that first session, followed by Hasgeek and then Anna. The topic that I'm kind of talking today about is interactive data visualization, and using Markdown is kind of like a head fake to get people interested in this topic. But I'm going to talk a little bit about my own journey of kind of trying to learn interactive data viz and how we could do that, and then what led me to kind of build or experiment with something like Markdown, and kind of say where I think interactive data visualization is and where we can go from there, right? So, I kind of started my career in the last decade as a management consultant, and the whole premise there as a management consultant was to change kind of the vector of the organization, right? So to change the vector of the organization, either the velocity or the speed, right? Or either velocity or the direction of that vector. And one of the ways, as a very data-driven way you would do, is you would try to create what I would call a killer chart, right? A killer chart that kind of illustrates what the organization is doing in a very data-driven way, either what the problem is or possibly point to a solution there. And the challenge at that time, or the weapon of choice for doing this for me at that time was just Excel, right? So you were mostly doing data wrangling in Excel. And if you had to do any interactive visualization, you would use, maybe put it on PowerPoint and put a couple of slides and try and create that interaction. And this approach of kind of a charting-based approach is really what all of us who do visualization or start off with visualization learn, right? It's kind of like the vocabulary of doing visualization. I know a few ways to describe visualizations and I keep using that, right? So it's kind of like a fixed template. As long as the data fits into that template, I'm okay to use that charting, and that works, right? And that works for a large number of cases, and that's probably one of the reasons data literacy builds up. But it's hard to do interactive stuff on that, right? In the charting metaphor, or at least in the last decade, there wasn't much to do interaction stuff on that. So how do you go forward, right? So at the start of this decade, so that was last decade, start of this decade, I said, let's try and do some interactive visualization. And one of the good books or good people who talk about this or used to do it much before was Ben Fry, who wrote the book called Visualizing Data, and he had this whole process of doing visualization in a very sketch-based tool called processing, right? And then later on there was processing.js, so you could actually put it on the web. And he had this wonderful example in the book called zip decode, right? The zip decode was really this example of mapping all the zip codes in India, and I was like, let's do that, mapping all the pin codes in the US, and I was like, let's do that in India. So I had no JavaScript capability to kind of do that interactive visualization, and what you do initially is you just copy, right? And the urge starting up is to copy, and that's not really a bad thing, that's how we learn. Most of us kind of find our own voice after copying a little bit, or sounding like a lot of other people for some time. And I created what at that time was a very nice visualization of pin codes in India. So it's basically just a map. It's not really a map, it's just a scatter plot with all the possible pin codes visualized. So it's just a pin code, scatter map stretched to look like a map. And it had some really nice interactive feature. You could type a digit of pin code, and as you type, you start to see the geographic layout of this. And you could also zoom into it, and it'll kind of go on, but you could kind of keep typing the numbers, and you would come to this, which is kind of your pin code. So if you say 560076 in Bangalore, this is close to where I live. I thought that was wonderful. I mean, even though I didn't really make it, I just kind of copied the code and kind of played around a bit to hack it to work for the Indian database, Indian pin code database. It was really nice. And this interaction was really nice because it kind of served one of the key purposes of data visualization, which is when you're trying to do data visualization, you're not just trying to confirm something, you want to learn something. So I ended up using this visualization in a lot of my workshops, trying to do kind of like, do you know which 5 are which states in India, right? Or which states start with 4 or 3 or 2 and 9? And 9 actually is not on the map because 9, there's no pin code that starts with 9 or it's linked to army. So there is no data on it, and you learn something from that visualization. So the interaction part was really, really amazing because you could learn something about the data, and you could kind of very interactively with a two-way binding between typing the data and the visualization, get that learning happen, right? But it was really hard. It was really, really hard, right? You are not only defining the visualization in terms of each data on each pixel, you're actually designing each of the interactions. You're basically hard coding and writing each of the interactions that are there. So you don't have to design both the pixels and both the interaction. And so this pixel-based approach using processing.js requires lots of code to really make it work, right? It's wonderful if you're trying to do generative art or more for data expression and you want to really experiment with visualizations of very different kinds, which are novel in nature and not really available easily through a charting library. But you need to manage each and every pixel and each and every interaction, and this is not really something I was at that level capable to do, right? So you have charting-based, easy to do, but then you have pixel-based, which you're trying to manage the canvas and really hard, right? So I said, okay, what do? I just gave up at that stage. I said, this is way too hard. Interaction is not something for humans. Let's go back to static viz. And let's go back to static visualization, but I didn't just want to go back to doing charts again, right? So I thought, well, there should be a better way to think about charts, and then figured out that there is actually a grammar of visualization, right? So 5 years ago, I said, let's learn the grammar of graphics, right? And the grammar of graphics was pretty amazing. I've kind of talked about in Fifth Elephant, I think 2 years back, on visualizing multidimensional data, talking about how the grammar can use to build a chart. And I think this was one of the things I talked about in the basic grammar. You take a data set, you parse the variables, you encode it using marks, you select the scales, and then you render it with a coordinate system, right? And you get a very nice visualization. And because you're using grammar, you're not really defining a chart type, you're defining a workflow. You're defining a flow of grammar transformations, which takes the data, encodes it into marks, scales it, renders it with a coordinate, and you can basically create unlimited visualizations using the grammar. And this was fantastic. So over the next 2-3 years, I was really into grammar of graphics and saying how we can do this. And there are many implementations of this. One of the best ones that I kind of latched onto at that time was ggplot, which is the grammar of graphics plotting system in R, a very wonderful library, and then kind of built into it right now to do wonderful extensions on top of that now that you can do a lot of stuff you need. And there are similar bindings in Python that you can experiment with, or any other language of your choice, Julia, Scala. But there is, so this is great. Now we have a grammar. I don't really need to be on the charting side. I don't really need to be at the pixel side managing each and every element of interaction. So I have a graphical primitives that I can manage and handle it, right? But it doesn't do interaction, right? It doesn't do interaction. So my whole aim of trying to learn interaction is not there. Now I can make unlimited charts and I can play around with it, but I'm still limited to static visualization. Right? So last year, I said, let's do interactive viz again. I kind of, having seen a lot of data journalism, people doing great work, and in India, people like Graminer, Mint, PyK, doing some of these works. I was like, let's go back and do more interactive database. And this was the time when the demonetization had just happened, so I said, let's pick this RBI database of how many nodes are there, and let's create a visualization. So I created a narrative visualization, animated it. It was kind of the color of nodes, right? The idea was, how big is the share of 100 or 1,000, 5,000 rupee nodes? And, well, it's basically 83% at that time, but I really wanted to see the transition from where we were in 19, or at least 35 years back, and kind of come all the way through and build it up, right? So this was great. I was like, okay, I can now do, and I kind of started to do D3, and D3 is really nice because it does implement the grammar of graphics, right? So this was partially built in D3 because it does implement the grammar of graphics, but it does not do interaction because there is no grammar. So the interaction element in D3 or any of the library abstractions built on top are all very imperative, right? They're all imperative. And imperative means you have to describe how each interaction needs to be computed, right? So it's not, you don't describe what needs to happen, you need to describe how each of those interaction elements would need to happen, right? So if you want something to hover, you need to write the code for that. If you need to make something link together, you need to write the code for that. And if you want to then render it differently, and you say, I want to use an SVG to make it happen, that's going to take a different interaction model. If you want to render it on a canvas, that's going to take a different model. Now, if you say, I have too many data points, and I want to render it on WebGL, that's going to take another different data model, because I have to describe each of these interactions directly, right? So it is an imperative style of coding, and most of you who've done imperative would know that you need to really describe each of the steps in making the visualization, right? So this, again, turned out to be okay for 1 or 2 projects to try my hand at, but this is not something that I want to kind of keep doing or keep using, right? Because this is way too hard, still way too hard, right? I call it way too hard for humans, right? Not for JavaScript ninjas or coding ninjas, but for normal people, it's the imperative style is really hard, right? So we need to find a different way to do this. Okay, so then I said, fine, this is fine, the imperative style hard, let's re-examine this graphical user interface tools that have been around there. Right? So there are these GUI tools that have been there to build, and they do a lot of these interactions. And in the trigger that happened the last few months was I was helping a startup kind of build a dashboard. So they had a product, and they were really trying to think of how we could build a dashboard on top of that. So, you know, we've done all the product, we have a real-time analytics system, we want to put a dashboard on it. And the message they were saying is that dashboard is a solved problem, right? So we looked at a lot of dashboarding tools, and, you know, they all have these drag and drop capabilities to make interactive graphics, and the idea was that this whole paradigm of making business dashboards or making GUI tools is like a solved problem. I was like, okay, so maybe this is the solution to kind of go down that path. So we should just drop this whole coding and writing stuff and just use these GUI tools to make it happen. Right? And I said maybe, and this is what happened when I tell people I'm doing a talk on interactive data viz, people come back, it's a solved problem, just put it in Tableau, why are you talking about this whole topic right now, right? What made me uncomfortable was, A, is it so simple? Okay, maybe it is. But then why do I not really see some good interactive dashboards, right? Because I teach this stuff, I consult on this stuff, and I see all kinds of tools people use from every possible graphical user interface, and there's never a really good interaction or interactive dashboard that I come across. And so that kind of triggered the same, maybe it's not that simple, right? So there is this kind of glaring gap between handcrafted, code-crafted, D3 or any library-based visualization that the data journalism people do, and you see those fantastic stuff. And then there is this business side of GUI created interactive viz, and you're like, this thing just seems too far out, too far out. And it's also a challenge when you go and talk to people, because people want to do that stuff in their business dashboard, but maybe it's not possible by the graphical user interface you do, right? So, this sounded really bad, and as I started to look a little bit deeper into this, I came back to, okay, what are the basic interaction principles, right? So Ben Schneiderman, who kind of talked a lot about, who designed tree maps and has talked a lot about interactive data principles. He had this thing about information seeking mantra, which is basically you overview first, then zoom and filter, and detail on demand. So that's kind of like when you're trying to define an interactive dashboard, this is kind of like the way to visualize it, right? Or way to think about it. But when you go to a business dashboard tool or every business designer tool, they kind of tweak this mantra a bit, right? So the information dashboard mantra is aggregate first, make a chart, link it, and then put a table on demand, right? So the information design mantra for dashboards is very different. So let's see what that means, right? I have an order table, or I will have a data table. I'm going to load a data table. I would create some aggregate measures. So, I create these nice aggregate measures. I would make 1D or 2D charts. Okay, so I will put them in a very block layout, one next to the other. I will link them with a few filters, and I would add a table list for details, right? So the information seeking mantra there when you start using dashboard tools is that translates into something like this. So every dashboard ultimately looks pretty much like this, right? And this is easy because now you can, unlock the data using a dashboard. So you're saying, I want to create a dashboard. If I have data, I want a dashboard. Okay, fine. I have a column and a data storage behind it. That's great. I have some reusable charts. So we're still in the charting metaphor. I can put them in a block. I can just about add the basics required to annotate it. Just about the basics, so titles and maybe headers a bit, and maybe highlighting on a hover. And I will just brush and link it together, right? So this sounded, way too easy, and because it's way too easy, it is like one design paradigm that everyone started. And then when I look back at how much time it used to take us to create something like a killer chart that I started the talk with, it used to be really hard. Like, really investigating what we need to make in the visualization, how to make it, how to make one good slide, how to link those 3-4 slides together to make kind of a killer chart or a killer conversation. That seemed far more away from what we have right now, right? So there's probably a difference between simple and easy, right? So, it's easy to confuse the two, right? The simpler the thing is to do, or the simpler the thing is to understand, often the more difficult it is to do. And I think that, a number of kind of people who do visualization talk about the same challenge, right? Most visualization dashboard designers or libraries would think about how can I scale this tool so that it can handle 1 million data points, or how can it create 10 million bar graphs, or 20,000 bar graphs for that matter. They're all thinking about how the scaling problem can happen. And if you really talk about anybody who is practicing visualization in a much more kind of custom way manner, they would always think about how visualization is a communication problem. I want to think about how to design this thing in a way that I can explore it, right? I want to explore the data, find the shape of the data, and be able to communicate that. That is the objective that I have, rather than just trying to create a tool-based, the word that I kind of use for is chartomania, right? So I have all these data, I have the technology to make these dashboards. Let me put them all together and kind of throw it out there, right? That's the dominant business dashboard model, right? And it is interactive, right? So there's obviously an upside to this. I could not have done a lot of this interactive visualizations earlier without this graphical user interface, right? So this GUI helps me do that visual analytics very easily. It helps me make better simple charts. It does allow me to have better aesthetics, and it is a bit of a modular and scalar structure to do interactive visualization. The downside, though, actually is much more. It kind of over-indexes on one particular design pattern, right? The design pattern of putting these charts together in a block and linking them together. It doesn't allow me to think about how I can lay the charts differently, how I can think about visualization and interaction differently, right? The shape of the data that is there is lost, right? right? The whole intent of finding something unique in the data and communicating that through the dashboard is gone when we just aggregate it down and put it there. Right? Mostly the focus is on just getting the data out there in some visual form rather than thinking about is there any insight or is there any narrative that we can make? And it becomes very impersonal and dry. So the quest continued, for me at least. And I'm gonna hear back a lot from people who would say, we love our graphical user interface, and we love our dashboarding tool, and what are you talking about in this? For me at least, the quest continued in the sense that I needed to find something that allowed me not to go fully into the graphical user interface, not necessarily require me to write 50 or 100 lines of imperative code to design one simple visualization, right? So we need a declarative grammar of interactive graphics, right? So we need something in which we can describe how visualization is done in the same way we can describe for a static graph. So if we can describe static graphics and we can build a graph, why can't we describe interaction in the same way? Right? And this is not an easy problem to solve. I mean, if it was, it probably would have been solved. But there is a couple of new things that have come which make it seem more interesting, right? There are a couple of attempts at this to do that, right? And the intent here is, again, to move in a declarative way, is I don't want to describe what the interaction should be. I want to just describe what the interaction should be. I don't want to compute it directly. So I just want to say, select this cell and on highlight, and I create a visualization rather than actually coding the entire action of declaration. So the tool that I kind of leveraged or went with is Vega Lite, and kind of Vega and Vega Lite are two sets of libraries. They come out of University of Washington. It's an academic group, but they have been part of a lot of development and visualization topics. So Flare came out of the same place. Mike Bostock actually was on the same place, and D3 comes from him. And Jeff here and his team have this whole ecosystem built around Vega and Vega Lite, right? And so last year at one of the Hasgeek events, so there's one advantage of coming to Hasgeek events, is in the last JS Foo, given my lack of JavaScript knowledge, I wanted to see how we could take something like this and make it simple. So I worked with two of the Hasgeek folks, Shreyas and Vidya, and we hacked together something at that time which would take, and we call it BizDown. Kind of like Markdown, but for visualization, right? And the intent was to take this grammar of graphics, which is very declarative, and allow us to create interaction. So this is on the web, so you can go to bizdown.com and you can experiment with it. So even though we did it last year, I haven't gone around and talked too much about it so far, because this whole interactive data visualization or interactive declarative part, which was part of Vega Lite, is still in beta or is still coming out. So they've just figured out a few of those principles, and I didn't want to go out and talk about static visualization and say how we can do static in Markdown. But now, because we have this interactive visualization, I have the ability to write this same visualizations in a very declarative fashion. So I can describe just the data and the mark and the encoding, which is the X and the Y and the color and the sizes. So that's still common to what I would do in a static visualization. But I can also now define what happens when I do some selection. So if I was to do a selection, and this is a brush selection, I am brushing one part of that. I define a selection brush, and I'm describing it of the type interval. And the moment I do that, I can then define what happens to color. So I want the default color to be gray, but when I select that interaction, I want that part to be highlighted. Right? Now this is just one of the examples in in Vega Lite. But the intent is that with just moving from pure selection to much more complicated selection ideas, we can go forward in it. So I'm just going to show the Vega editor, which also has an example of some of these interaction efforts in which I can brush on just the overview. And so this interaction effect of overview and detail, which is really hard to write, can now be written in a very simple fashion, and I can actually write this in an interactive way, right? And one more example before I move on to what the implications are. Something that's also really hard to do, cross-filtering. So trying to filter across many rows. To write that in a declarative fashion, imperative fashion will take you a long time. But now I can filter through multiple, highlight different areas, and I can actually filtering across each one of these elements. Right? Now, I don't want to take too much credit of doing it, because what VisDown does is in essence very simple. It just takes what you would normally write in Vega Lite, and they have very well documentation, which is a JSON one. It just puts a markdown editor in top of that and allows you to then write in markdown codes. Instead of saying colon, colon, colon and Python, you just say, backtick, 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 Python, you just say backtick, backtick, Viz, and you define that declaration, right? What this allows though is that now you can actually write narrative documents and embed visualization as well as the commentary around that in a very easy way, right? And I think that there is strong potential from building these declarative tools. This allows us to do a lot more many things, right? So I'm going to talk about 7 things that can happen now if we have much more of a declarative interactive visualization. Right? One, it allows us to do something which is even more than doing dashboards or just explanation, right? So the typical end of the spectrum is explanatory graphs or exploratory graph, right? But if you really want to understand something, you can think of this end of stories, that end of dashboard, right? But if you really want to get people to get some insight, you can think of it as explorable explanation. Can I do both explanation as well as exploration at the same time, right? And this original intent or idea obviously came from Brett Victor. I don't know any of you, he's a brilliant writer, talks about up and down, the ladder of abstraction, and a lot of topics around how to create interactive or explorable explanation. And because now we have tools which are declarative, people have come and built other markdown-based tools which allow you to do, so there's, I'm not the only one experimenting with using Markdown as a way to create. If you are keen to try other tools which are built again on top of Vega Lite, or you can even write more, there are other experimental tools which allow you to, this loads, very similar concept, write Markdown on the left, and you can then build an exploration dashboards on the other side, right? So, and this goes much more beyond than just adding one visualization. You can actually create reactive components and play around with them and create it as part of this. So this is same idea of creating a document which is just not only visualization, but now you can actually embed ideas and explain ideas. For the machine learning folks, similar stuff. that you see on distill.pub, for example, is another way. It is now easy for anyone else to create their own distill.pub kind of documents, which explain why machine learning is working the same way, the way it does. Let me just go back to this. It also allows you to do datum first design, right? So instead of thinking about aggregation everything, with the ability to explore rapidly, you can actually then take each data point and see how you can visualize it, right? So not just think about aggregating down everything, but thinking about how each element can be visualized and how I can kind of get that insight out of it, right? You can also think about, instead of showing single, can I show all of the data, right? So can I do high density charts? And this is a lovely example of how you can build a chart which as you increase the data density, the configuration of the chart itself changes, right? So if we can write declarative stuff which handles data density on its own, we don't need to again think about how we need to define a bar chart or a hex bin versus a scatter plot, right? So as the data density increases, we have the ability to kind of show all of it, right? We can then do more things around visualizing uncertainty, right? So how can we go from just one element of showing certainty to what we really want to show about how that bar is actually distributed, visualizing uncertainty, right? And visualizing uncertainty, because uncertainty is really hard because it adds one more dimension to it, right? But now we have exploration tools, we can actually do a lot more of that. So we can easily create charts like this, which would otherwise be not so easy to create in a charting-based library, right? And the last 2 points, which is we can think from moving away from blocks to thinking how we can compose something, right? So move from just a single block-based design that we've kind of picked up on, we can think about composition. So this is a dashboard which is much different than what you would see built on Vega, which is again declarative, and you can actually play around with this and build this much more rapidly than you would actually be able to build if you were trying to use a GUI tool or actually coding it directly. Right? Think about adding annotation as a first-class citizen. So not only thinking about how the chart works, but thinking about how we can also then add annotation as another layer, because we can start to declare it and be able to embed it into the charts. And finally, we can think about adding layers or doing layered interaction, and think about the charts not as one single layer, but multiple layers, and we are interacting across each one of them and creating visualizations and interactive visualization. All of this is possible once the tools to make it move much more away from the imperative design or a fixed pattern in a graphical user interface. And that's why I think kind of there's a significant upside to kind of declarative-based interactive tools, right? And I would seriously urge people to kind of try out BizDown or IDLE or any of the other languages. I know many of the data scientists would be wondering, I never want to go out of my basic design tools and move to this. Well, there are bindings there's Altair, which is a Vega-like binding in Python. There's R Vega-like, which is a binding in R. So you can also experiment this within your own workflow if that is what you prefer. But I really think that moving to a declarative design helps us kind of build a better mental model of the visualizations or the data. We understand much more about the story. We can both get a macro and macro pictures. We can build and understand certainty or uncertainty in our data much better. We can see the pictures all. We can actually do much more narrative design, and we can work across these layers of abstraction. I'm going to stop here. With one line code, one human life closed. Observed is everyone's life, in the particular is the universal. And I really think that's one of the things about interaction, is that you can actually then go from a singular story, from aggregation back to single elements and move between these two layers, right? I do a lot of storytelling, and we always find we connect with stories because we can see the individual element. One of the challenges now with databases that we've gone to so much of aggregation that we lose that individual story that we really want to find. And I'll stop at this. BizDown is available at bizdown.com. It's an open project. Please contribute and see if you want to experiment with it, or you want to experiment with the other of the declarative tools that are there. I'm mostly at amitcaps.com, and feel free to reach out to me. I'm pretty much Amit Caps everywhere on the web.
We have a few minutes for questions and answers. If anybody has a question, please raise your hand and we'll get you a mic.
Hi, Amit.
Hi.
My name is Sushant, and I represent a company called Cookie Analytics, where we are into mainly visualization. I resonate with you, what you have mentioned and whatnot. A couple of quick questions. It's a two-part question. Visdown, right? There is something called high charts. Have you worked on high charts? Have you seen high charts?
Yes.
So it has a lot of interactivity, and also it goes with the traditional finance guys data model representation
Sure.
and whatnot. My main concern was like whenever I want to go with the interactive tool for visualization, the data to take example as a D3. I'm supplying data, but the data for every chart or every representation has to come in a different format, which is not possible in most of the real-time scenarios.
Right.
How do you deal with that? I mean, what is your thoughts on that? Because data is what we are all here for, and data cannot be supplied to different visualization in the similar manner, but that is not possible. I cannot keep supplying different types of data in financial space. So
I think there's nothing wrong in choosing a tool that fits for your need, right? So let me not leave you with the impression that I'm against charting, I'm against visualization, graphical libraries. If HighChart works for you, very nice. But even a charting library has a given format. You need to still define what the data is going to be, how the data would be represented. And the data format is very limited to one particular chart, right? The reason for moving to grammar is that it allows you to then not changing the data, but just changing how the grammar is happening, how the visualization is representing. You can move between charts very easily. Once you have interactions, you can move between interaction much more easily also, right? So the ability to translate from charting to grammar is really to give you ability to broaden your horizon, broaden your envelope to select charts, and now broaden your envelope to select visualization. It does not prevent you from, it is, in my understanding, much more flexible than a charting library is going to be.
We have time for one more question. Ooh, up in the balcony.
Oh, wow, okay. There is no mic. The mic's not working.
Well, I can tell you that we have an OTR, an off-the-record session in data visualization today at noon. So if you don't get your question in, please come to room 1 for the data visualization OTR at noon, and you can ask and talk then.
Okay, thank you so much.
Thank you very much. So our next speaker is going to run across the stage and do his setup while I introduce him. For those of you who've just arrived, I want to remind you that you're probably sitting on or have moved your feedback form. The feedback forms are really important to us, and I will continue to remind you to fill them in. This is the perfect time to fill in your feedback from the first speaker. We'll be collecting them throughout the day. There are 2 forms. There's a morning form and an afternoon form. Your feedback helps us make conference better, so take a minute and fill in the questions for us. Oh yeah, you can fill the forms in online as well. There's an online form and you will receive an email to a link to that form later today. All right, I think they're just about ready. So we talked about marks in our first talk. This talk also is about marks, but not data visualization. This is about children's school grades, or part of it's about children's school grades. One aspect of a child's life contributes to their school performance. There was a huge, huge study done about this, which produced a very, very large data set, a very large and complex data set. Well, our next speaker, Anand, who's the co-founder of Grammarly, knows how to get to that data really quickly, really find the key components of a large data set. And he's going to tell us about how he did that with this survey and with other pieces of large data sets, but hang on. How's it going? Check, check.
Check, check. So in 2015, the NCERT came to us and said, we'd like to understand how to visualize the results of one of our surveys. Specifically, they had done a fairly large-scale survey. This was for class 8, and they had done one similarly for class 3 and class 5 and so on, for about 2 lakh students. And the intent was, let's see at a grand scale, what is it that influences marks? Actually, the purpose was beyond that. See, the thing is, the first time a child's mark is really compared against everyone else is in class 10. And before that, there is no data. And there are a lot of people that have been complaining about this. So the NCERT said, no, we will have a response to all of these surveys by creating a mega survey. Now, the thing was, when they said, now what we want you to do is help us understand what are the drivers of marks. Took a look at the data, and this was what the data looked like. Firstly, before I go ahead, a copy of this data set is available in the URL sanand.net/test/nas.csv. I just temporarily put it there. I have no idea how long it's going to be there, so feel free to grab it when you can. The striking thing about this data set is that you'll notice that there isn't a single number, and it's pages and pages of columns of non-quantitative data. And with quantitative data, we don't have a problem because we can, at the very least, do a regression and say this variable affects this variable or not. But with qualitative data, this was proving to be a challenge. The thing is, this is not an unusual problem. Not only was it not an uncommon question, it was in fact the most common question that we were asked. When we started up, that was in 2012, we were just playing around with data, and one of the questions that we wanted to answer was what explains, for example, cricketers' strike rates? What makes a difference to the players' strike rates? And the bulk of the data was categorical. Which team are they in? Which country do they play for? How long have they been playing as quantitative? But most of the characteristics were qualitative. When we were working with Sumna Poetry, they said, we want to understand what explains the birds' deaths. Out of every 100 birds that we place in a farm, if 95 survive, that's like a fantastic thing, but typically only 90 survive, and between that 90 and 95 is our entire profit margin. Now, what information do we have about these? Well, we know roughly whether the farmers are experienced or moderately experienced or inexperienced. We understand the type of material that is used for the floor. We understand the type of cooling that is used, type of this, type of that, all categorical data. Or for instance, a pharma company said, we want to understand what explains the reasons for why our service request processes are delayed. A bank said, we want to understand why our servers are crashing. Star TV said, there's a serial, and this is just one among several serials we were talking about. We want to understand what impacts the TV rating. Tell me, what can I do to influence the TV ratings? This is a talk in itself, but let's not get into that. We are currently working with a bank that says, we want to know who's going to leave before they actually leave. Well, at least before they actually tell us whether they've made their decision or not. And all of these have just one characteristic in common, which is that we are trying to answer a certain pattern of question, what explains something. And the bulk of the data is categorical, and because in 2012 we didn't have a technique and we still don't have an alternate technique, we created one. And this is called group means. This talk is basically about this. There is a library, I will share the link with you towards the end of the talk. But the focus of this session is on explaining what this technique is and how it works. Before I go ahead, I'll talk about a couple of things. Firstly, this is a simple tutorial. I'm not going to talk about big data, not going to talk about neural networks, I'm not going to be talking about machine learning, not going to be talking about AI. The most complicated thing that I will be covering is the t-test, and you don't need to know much about the t-test to be able to get this technique. But as Amit said, right, there is a difference between simplicity and ease. I'm focusing on simple. Ease is a different matter altogether. Also, I'm not going to try and make this entertaining. I'm just going to focus on teaching because, as Red Victor put it, right, people mistake entertainment for education. You get out of an interesting talk, you say, oh, that was really cool. What did you learn out of it? I don't know, but it was really cool. And I'm guilty of that myself on a number of occasions. I'll keep it very down to earth this time. And we'll be using spreadsheets. I was tempted to say Excel, but that's the purpose is not to say Excel is great. Excel is great, but that's not the point. The point is that spreadsheets are great. You may have heard of or even read Fred Brooks' No Silver Bullet, which talks about how after the advent of high-level programming languages, there hasn't been something in programming that dramatically transformed productivity. Though there are a few exceptions. Databases are one such exception. Spreadsheets are another such exception. And I truly believe that spreadsheets are one of the greatest gifts that software has given to mankind. It takes the ability to process data away from an esoteric small group that has access to sophisticated programming tools to pretty much the bulk of the world. And you could argue that more analysis is being done today on Excel than pretty much anything else, or any spreadsheet for that matter. That's all we're going to do. We're just going to play around with spreadsheets. What I'm going to do is actually take up an exercise. We will answer one simple question using this data set. Do calculators, does the use of calculators actually help students score more in mathematics? So let's open the data set. I'll make it a bit bigger, hoping that you'll be able to see it, but I have no idea if that's what's the right size. Is this good enough? Are the people at the back reasonable? Okay, fine. So the data set is fairly straightforward for each student, and I've taken a small sample of the data set. It's only the students in the state of Maharashtra that I'm picking. So we have about 8,000 students that have been sampled in Maharashtra. So we have a student ID, which is a long number. We have a district code. We have the gender. We have the age, and so on. And the information about calculators is stored in a column called use calculator, which is sometimes empty, or it can have a yes or a no. So in order to explore this, what I'm going to do is create a pivot table. I used a shortcut. Let's not worry about how I got to the pivot table. And I'll answer, I'll say, let me group by the use of calculators. So we have three possibilities. I'm going to zoom in so that you can see it a little easier. Yes, no, or blank. So let's see what is the average mathematics marks of the students. Rather than count, I want the average. But to be fair, I also want the count. So let's take some other column like the state and do a count of that so that we have, yeah. So roughly, let's in fact represent all of these as percentages. So I'll have this as a percentage of the column total, and I will represent these as they are, but obviously I don't need this many decimals. So let's get rid of that and show it to a smaller position. And I also find it easier to color code it so that you'll be able to quickly see what the performance is. And this also is something that I only need maybe 0 decimal places. So what this tells me is, yes, using calculators gives me a higher score in mathematics than no, not using calculators. And interestingly, the people, and there are 24% of them who left this blank, not indicating whether they're using calculators or not, are faring even worse. Now, why they've left it blank, I have some theories on. It could be that they didn't understand the question. So which means that you have bigger problems than the use of calculators. You have problems in the language, right? But that's just a theory. However, what I can say is that, at least from this, the use of calculators seems to give people a higher score. Now, having said that, however, correlation is not causation. It's just a hint. Now, there are two ways to take the statement. The first is to focus on the first part, which is to say correlation is not causation. Therefore, the fact that I have found a correlation is meaningless and is therefore not actionable. However, that's throwing the baby out with the bathwater. When on the other hand, you look at it and say, look, here's a hint. There's something going on between calculators and mathematics. Not that I needed this analysis to know that, but I was picking an obvious relationship in the first place. It at least merits investigation. Maybe those that score high on mathematics tend to like calculators and use them. Possible. So it could be in reverse. But at the very least, the use of calculators and scoring high in mathematics do seem to be associated. And we can check this association for many other things. So for example, can I answer the question, do computers help in mathematics? Let's quickly do that. So instead of using calculators, I'll get rid of that and say using computers. And the short answer is yes, using computers also helps. Not using computers doesn't help that much, and obviously not answering the question does no good for the student. But you'll notice that the difference between these is not so large. But before we go into the difference between these two, let's ask the question, is this meaningful or is this just plain random? When I was a kid, my name starts with A, and therefore I get called in class for many things in alphabetical order and end up being one of the first, so which puts me at a certain disadvantage. I've got to be a little more prepared because I could be called upon right at the beginning. But then people also said, look, that's an advantage because then you're getting trained to be more prepared for impromptu things, and that's going to be an advantage. Now, this is a classic question, right? So does it actually make a difference? Does the first letter of the child make a difference to their marks or not? I'll do a quick poll here. How many people think the first letter of the child makes a difference to the marks? How many people think it does not? Okay, does not is the majority. So until last year, I was consistently telling people that no, it makes no difference whatsoever. And then I went back this year and did a rehash of this for specific states. It turns out that in Karnataka, it does make a difference. And those whose name starts with the letter A do score higher, and it is statistically significant. But this isn't a talk about numerology. Let's not get into that. The thing though is we do have the ability to differentiate between pure randomness and what is actually significant by doing the t-test. For those of you who don't know the t-test, it's a magical thing that basically tells you if two groups have the same average or not. For those of you who know the t-test, you know too much. So let's apply the t-test. I want to check whether the use of calculators is actually making a difference or not. Now, what do I want to compare with? I want to see if the population as a whole is different from the sample that uses calculators in a statistically significant way. In other words, is the average of this higher than the other? So how do I do that? In Excel. So I'm going to open that set of people who do use calculators. That's this set. And I'm going to take their maths marks, which is a column somewhere towards the end. Okay, that's their maths percentage. I'm going to put this on a new column here. Once I've copied it. And I'm just going to zoom in. So what I have is data for approximately 3,000 students who have used calculators, and each column represents one of those students. Now, I don't have maths marks for everybody, but that's okay. The other population that I want to take is basically every single student. So let's take that. And again, I don't have maths marks for everybody, but that's okay. Now, I will, in the data analysis tool pack, which is an optional add-in that you can install in Excel, there are a whole bunch of t-tests. There is a pad, two-sample, blah, blah, blah. There's a two-sample assuming equal variances, and there's a two-sample assuming unequal variances. Now here, when you get stuck, the simple rule of thumb to follow is try them all one by one. It doesn't really make a difference. The good part about large data is that the whole principle that statistics is based on goes for a toss. Now, statistics is based on the assumption that it's very difficult to get data. Therefore, we have to make the best use out of it, which means that we have to sample because working with data is difficult. Getting the data for the sample in the first place is very difficult. With data analysis, what we have is usually the entire population. And we have systems that can process billions of data points, like on your mobile, let alone your desktop. What sampling are we talking? The difference between equal variances and unequal variances for this particular data set is in the 16th decimal place. We have bigger problems in the 16th decimal place. So let's just do the t-test with equal variances for all I care. And this says, tell me the column which has the first data set and the column that has the second data set. So we'll pick the first data set and the second data set. I do have labels, so I'm going to ignore those and click OK. And this tells me that there is, well, it tells me a bunch of things. Now, the important thing to know about statistics is that usually everything is ignorable. Most of the stuff that you're given is not really relevant. The one thing that matters is what the difference, what the result of the test is. In this particular case, the test tells me that the first group, which happens to be the calculators group, and the second group, which is the everyone, the difference is 33 versus 31. This is a small difference in the in this. Now, the other important thing is to look at the p-value, and there are two p-values. Let me start with the two-tail, and then I'll tell you what the difference is. So this one says that there is a 0.00014 p-value. Now, what the t-test does is tells you whether one particular population or sample is different from another sample or population. The base hypothesis is that they are the same. What this is saying is that there's a 0.00014 chance that they are the same. Basically means they are different. And statisticians will word this as the null hypothesis has been rejected. What basically means is your original statement that they are the same is not true. In other words, they are different. So, in other words, it's saying that there's less than a 1% chance that these two groups actually are getting the same marks. In other words, there's less than a 1% chance that the use of calculators does not help. That's pretty decent. Now, when I make that statement, some people may wonder, should we take the one-tail test or the two-tail test? Well, look, if it makes a difference, then the conclusion is questionable in the first place. If one is tiny, the other will always be half of the first. And the difference between these, a factor of 2 is nothing. We are talking about orders of magnitude here. If you get a conclusion that's probably 1% wrong, probably worry a bit. If you have a conclusion that's probably 0.1% wrong, then say, okay, I've got a decent confidence. Now, between 1 and 0.1, there's an order of magnitude difference. So, you really shouldn't be worrying about it. But of course, the t-test suffers from the classic XKCD problem, right? So, you apply a t-test, and I've got this cartoon online somewhere. Significant, yep. So, jelly beans cause acne. I've never really figured out how to pronounce it. So, they do a test on whether it makes a difference and whether specifically the color of the jelly beans makes a difference. So, does purple jelly have an influence? Does brown jelly have an influence? Does pink jelly have an influence, etc.? And all of this is done with a p-value of 0.05, which means that, look, just make sure that there's at least a 5%, there's no more than a 5% chance that you're wrong. You do all of these, and somewhere along the line, one of these, like green jelly, has actually a significance of less than 0.05. You say, oh, okay, maybe that causes acne, right? And of course, the conclusion gets totally distorted to green jelly does actually cause acne. Now, obviously, the statisticians, the non-statisticians among you didn't get this joke, but what it really meant was, if you apply something like a t-test, not on one sample, but on dozens and dozens of them, sometimes you will get things wrong simply because you've chosen a weak cutoff. You said 1% is okay. Now, what that means is that if you do that 1% is okay 100 times, there's a pretty good chance that one of them will actually be a wrong conclusion. So, in this particular technique, we are applying the t-test on a large variety of categories. We are checking for calculators, we are checking for computers, we are checking for X, we are checking for Y. So, the cutoff that we need to take for the t-test is a lot stricter than otherwise. What that cutoff is entirely up to you, really. Now, the last thing is which one helps more. So, we saw the result earlier. For computers, the result was that there's only about a, sorry, this was calculators, right? Yeah, for calculators, there's about a 2.5 percentage point difference. But whereas for the use of computers, there's only a 0.2% difference. Now, let's assume that this is statistically significant, and it turns out that it is. What this means is that more than whether this was important or not, what matters is that the use of calculators is probably a stronger correlation with maths marks than computers. Computers is fairly generic. So this gives me the ability to say that calculators are a stronger influence on marks, at least maths marks, than computers. And this is the basis of the technique. What that leads to is a result that's on ramna.com/NAS, and you can happily explore. It says, here are all the factors that make a difference, and if I look at the maths marks, what makes the largest difference is the father's education and the father's occupation, understandably, and computer use. Maharashtra was the data set that we saw. Nationally, there's a huge difference, and there's a big difference between states, which we'll come to in a bit. followed by mother's occupation, helping in households. What helps total marks? Father's education and occupation, mother's education and occupation. This is a standard pattern. Parents help more than anything else. And we figured a bunch of other things as well based on this, like watching TV, right? How does it make a difference? Turns out that watching TV once a week is roughly the sweet spot, but not for mathematics. Students who watch TV even once a week or particularly excessively, they just tank in their mathematics marks. Father's education makes a huge difference, but we find that in patriarchal societies like Punjab, the mother has a larger influence. In a matriarchal society, let me show you what it's like in matriarchal societies. Let's take West Bengal. So in West Bengal, the influence is primarily the father, even though it's a matriarchal state. And in places like Punjab, the highest influencer, oops, I didn't mean to do that, yeah, is primarily the mother, which is kind of counterintuitive in one way, but maybe intuitive because they are staying at home and they are the primary caregiver for children perhaps. Cricket, when we applied it, we found that when you are playing first, when you are batting first, what really makes a difference to whether you will win or not is which team you're playing against. But if you're bowling first, what makes a larger difference is who's umpiring. Oh. And we have the list of the umpires who are very strict or generous. May I come in, madam? Turns out that when you want to pick costumes for Sanjana, it makes no difference what costume you pick, they're all equally good, but she is a disaster in jeans when it comes to TVR ratings. I haven't seen the serial, I don't know what she looks like in jeans. But on the other hand, night song sequences work phenomenally well for her. See, the thing is, all of this is based on relatively simple techniques, but the automation behind it and a certain amount of data cleansing is what goes into the bulk of the problem. That's the repository, gramnar.com/autolysis on GitHub. It is extremely well documented. It has a one-line documentation. So please contribute. We'd love to see more people pitch in on this and build a repository out of it. Thank you.
Thanks, Anand. That was a very interesting topic. Now I want a large data set of my own. So our next speaker is going back to the data visualization mode, and he's a cartographer. Of course, you guys all use maps, and you know that maps are like possibly the ultimate in data visualization. Cartographers have been using data visualization to talk about the world for centuries. And in modern digital maps, well, gosh, the possibilities are endless. You can take almost any data set and map it either as a physical map or a more interesting abstract map. Ragasi Sharma, who's a designer at Mapbox, is going to explain some of the ways that they design geovisualizations.
Cool. Second question, how many of you used a map to come to this auditorium? Not so many, huh? Like, few of us probably using the Hasgeek app to figure out how the venue is, but few of us already built a map in our head. So we had like a mental map of how this place is. Some of us are Hasgeek regulars, so they already know this place very well. The third question, which is obvious in our talk, is how many of you have used data and put them on a map to show in a visualization or in a project or in a dashboard? Awesome. Okay, great. So that means that a lot of you have already seen some of this stuff, which is great. A lot of you have been trying to do this stuff, which is also great. And some of you probably would be scared by some jargon, which hopefully by the end of the talk, you would not be scared of. So to quickly start off, I work at Mapbox. It's a platform for developers and designers to create basically different kind of stuff with maps. You would want to make visualizations, you would want to make a dashboard, you would want to make a tool which shows how delivery is happening, or if people here are using Snapchat, you want to use Snapchat and see where in the place are different people's photos. You would use Mapbox or a tool like Mapbox. So the way we like to call it, it's like a Lego building pieces. Take different blocks, put them together and make what you want to make. So this is roughly what Mapbox is. And my work at Mapbox, I work as, we all know about conventional charts, but some of us are not so familiar with what to do with a map, right? Or how to even approach that problem. So what can we do? And the second part, in case you've already figured out how you want to show your data, is to think about how do I do it well? Or maybe if I'm making, say, a choropleth or a cartogram, what do I keep in mind so that I can do this well? And that's roughly the two things that I'm going to talk about. A very quick list of things that I want to pick. So I don't want a jargon drop, but I want to use this as our itinerary for this talk today. So gonna go and keep checking one thing off our list and see how we're doing, right? So quickly start off, talk a bit about geo, about maps, about things that are there that you would want to put on a map, and then quickly move forward. All right, so let's get started. This is a very typical map visualization. This shows basically like different bus stops that are there in Mumbai, right? You probably would recognize the shape. What I want you to think about is the layers that are happening here. So currently that you can see, there are two major layers. There is this data of these nice firefly-like dots that have been shown on a map. And then there is the underlying data that's actually the map data, right? So there's a shape of Mumbai that you all can recognize. There is a label which tells you that it is Mumbai. There are these small airport symbols, and there are roads, etc., etc. So for any visualization that I'm making, I need to think about two things. I need to think about the geo aspect, and by geo I mean what is the map, what does the map look like, where will the data go on top of, and second is the actual data. So that is your own data. You have like a CSV, a topo.json, a geo.json, or different sort of data sets that you already have, and how do I get that onto a map? So the reason I'm talking about this, and that's a very small segue that I want to do, is to just get everybody on the same page. And also like break these very obvious terms that people generally talk about in geovisualization, which I think is very easy for all of us to know. So let's just quickly think about it. First, there are three types of things that you can make on a map or you can show on a map. They can be nodes, ways, relation, which is just fact. It's always interesting to try and change this map itself. So if I'm going to show data on top of this map, I don't want to see the highway Sheik 275 stand out so much. Maybe I don't even want things to be in different colors so that I can use those colors on my map. So suddenly, we could tweak this by choosing a different base map, right? And this is a very small sort of segue which I want to do to just get that point across. That at times, you would want to compare and see how does the underlying map look like and does it help show my data well. So just to kind of throw some points on it and see the difference that on the first map style, which is the streets map style, you can start seeing that the data is visible, but kind of conflicts. There are so many other things that are catching for your attention. In the other two map styles, you suddenly start focusing your attention on the data that you want. And in a sense, in any good visualization, your first and primary goal is to make sure that the data is easily visible. So that was the introduction. Just a quick recap, you need to think about your base map and about the data before you get started. A quick segue also here. on what could be there, or what exactly is a map and a visualization, and where do they kind of fuse in. So while we don't conventionally call it a visualization, seeing traffic on a map is itself a visualization. And that's something that we're already using very regularly. But it doesn't really feel the same as, say, conventional visualizations, because it just feels part of the map. Suddenly the roads that you already know have a color attached to them, and that color shows whether there's high traffic or low traffic. And that's an interesting sort of way to visualize data, where it doesn't really stand out so much in your face as something that's been put on top of a map. Another very cool example that I love, which might not be very visible here, is to see Google Maps. And in Google Maps, you can see some areas that get highlighted, which have a lot of popular places in it. So let me just try and see if I can get this here. If you notice, this is the 100 feet road, and you can start noticing that very subtle yellowish tinge that's been added to the map. That makes you realize that, okay, the part around the road here has a lot of interesting places, whereas the rest of it doesn't. These are very subtle sort of visualization techniques that people do to add onto a map, which doesn't feel suddenly like, oh, there's a big circle on a map, or there's a big shape on a map. And these are super interesting to kind of see. Oh, sorry. Let's come back. So yeah, this technique is super subtle in tweaking the layers of a map. This is also a very niche technique, and for most of us sitting here, we don't really want to do this much. So we want to try doing something very, very basic. And by basic, I mean, let's start with the most basic thing. I have a bunch of dots which represent something. I want to put them on a map. So let's get started. I'll select a base map. In this case, I've selected this very light sort of map, so it doesn't really stand out too much. And I've added a bunch of things here. These are all the bus stops that are marked on OpenStreetMap for Bangalore, right? And you can start seeing this. It looks okay. There's too many blobs. There's places where they're getting overlap. And while we're getting all the attention with the data, I think it's getting too much of attention, right? So quickly changing things and playing around with some visual properties like opacity. Reduce the opacity, and this slightly gets a bit blurry, but also starts highlighting some interesting parts of the data. So you can start seeing some clusters around a particular set of roads which start making this more interesting. Let's take this further. We could use color to try and show some other property of data. So in this case, I might want to say, out of the bus stops that are marked on OpenStreetMap, which of these seem to have some sort of a wheelchair attribute? Are they wheelchair friendly? Are they not friendly? Is there any data about it? Suddenly, I can start using color to make some of these dots pop out. And next, I can start using size as well, right? So now suddenly I can add a few more properties and start changing dots to start looking bigger or smaller based on which one is important or which one is the data that I want to stand out the most. And in essence, what we just did, for folks who've already been doing visualization for a while or have been reading some really good text, is essentially just picking visual encoding different variables and just applying them in the map style. Right? So for those who aren't used to this, there's a lot of literature written about what are the different ways in which I take a particular sort of form on a map and let data denote, different things on it. So you could change color, you could change size, you could change direction, etc., etc., etc. So feel free to kind of look this up. There are a lot of different people who've given different sort of explanations to it. But before we move forward, I want to do just one small sort of mention here about how this is separated. So when we have our data, for those who already have been using a lot of data sets, there's a very clear difference between the data that is continuous, so it might be numbers, or data that is categorical, which could be discrete values. So for example, in this case, you can see that if your data is, say, how many buses go on each bus stop, that's a number. That changes from 0 to maybe 10 or 100, and you might want to use a gradual scale for it. Whereas if you have something that is each point being each quality of data or each type of data, for example, what are the different types of, let's say we want to represent different types of facilities available at different bus stops. Right? So there isn't an inherent numerical order in them, and there's no inherent quantitative order in them. And that's the place where you would want to use the first section, where you identify them with colors maybe which have different hues and stuff like that. So just like I want to get some of these very basic stuff out of the window so that now we all feel actually. So it's a fun way to get started with something as simple as putting dots on a map. Here's another really interesting case. In this case, they're showing earthquake data over the years. They're using very subtle techniques of time as well as opacity, and there's also this fun symbols thrown in. So suddenly there is a triangle which represents volcanic eruptions, and then there are these two different colors which are being used. And suddenly we start seeing some really interesting use of something as basic as putting dots on a map, right? And this gets really interesting. You can make this interactive and you can start doing some really cool stuff with it. You can also create some really controversial pieces with this. For example, this is a racial segregation in New York and neighborhood areas where each dot is colored based on what is the common sort of race that stays there. And these become really interesting to show the detail in the data that you have on a map that we all are so familiar with. But there are times when you would want to highlight insights, and it's time like these where you would want to use, say, the size a lot. In this case, this is a visualization over time where you're showing how many jobs were lost or gained. The color is denoting that, and the total number is showing the impact, right? And you can start seeing in the initial part the bubble burst, the .com bubble that burst, and then the recession that came in. And this is like a graduated proportional symbol map if you enter the names. But there are these techniques and they very quickly hit a sort of a wall, right? And this is like a very fun thing. This is essentially all the potholes that are there in New Jersey. And while the intention is really great, it doesn't really communicate much. And what's happening is that if we start plotting individual points on a map, there's only so many points that we can put. And after a while, we'll really hit a limit as to what data can be shown. And like this is a cue for all the folks who are in big data or like huge amount of data saying, yes, this doesn't work, maps are useless, let's throw them out and let's use big data for something else. But let's not get ahead of ourselves. So a very easy way, the first obvious solution to this problem is to cluster, right? So we still have the dots, we still show individual dots on a map. But if there are too many of them nearby, we cluster them and make a bigger dot, right? And we can change the clustering based on the size, the type, and also add some subtle effects. Like over here, you have some color that's been added to highlight more and less. And this is basically the Women March that happened a few months back. Not trying to be political here, but this is a great example of what you could do with this. So essentially, with dots, it's really interesting if you keep in mind the different visual encoding principles that you have. And it's super important for us to make sure we control the density. So suddenly, if there are too many of these, we want to figure out something else. And apart from clustering, second something else that we are all very familiar with is choropleth, often called chloropeth, but it has nothing to do with chloro in it. But what we're going to do here is something very simple. Instead of showing individual dots, let's count how many dots appear in an area that we are all very familiar with. So different states of US, we all know how they look like. Let's count how many are in one and just show the data, right? So suddenly now it becomes very easy to show a summary of the data that you have in shapes that you recognize. So this is one example where you're using light to dark color to kind of denote the sort of density or how much amount is there. This is a pretty good chart by Quartz. Whereas this is another example by Mike Bostock, where he's using two things very subtly, changing the hue a little bit and mostly changing the brightness, right? And this is like a third example. And in this example versus in this example, you can start seeing that there is a change in how the story is being told. This is going from light to dark, so the darkness really stands out. Whereas in this case, both the edge points really stand out. So this is a good example of how you would want to use color in a choropleth map and trying to see if you want to make a diverging scale, whereas there's something that is showing the positive or the negative part of your data and highlighting that much more than the average data. Or you would want to just use a single sort of scale that shows the edges or the maximum of a data set, right? So just quickly running through this part, but That's essentially what choropleth would be, right? They would give you your familiarity, but the only problem here is that the data isn't always based on the area, right? So for example, in this case, or let's take the first case, each state is being colored, but we still don't know where exactly or how much of that state actually has humans to begin with, right? And this leads to these really fun visualizations where people say, oh, the places which tend to have a lot of McDonald's, the whole map into small things that you would want to call bins. So I'm going to quickly move through some of these examples just to get the point across about how diverse the map visualization scene is and where you would want to pick which one to get started with. So here is an example of hex bins. So essentially breaking the map into hexagonal shapes and then counting the number of or the point of data or highlighting the data that you want to highlight. So this is no longer too dense with too many points. It's no longer too abstract or very, very high level like choropleth. It's somewhere in the middle. Each hex bin is equal sized. So it gives you a better perspective of how the data is distributed and makes things really interesting. So there's a really lovely journalism piece on Z on Germany and how Germany, even though the wall between East and West Germany broke down, still very segregated in different sort of attributes. But what's really interesting is that they're using these very nice circle bins here. So break Germany into small pieces, all of equal size, count the data that you want to show, and then show it using color. And this becomes really interesting to see the slight sort of segregation, the sort of patterns that really show up. So in a sense, if you're using bins, it's a great idea. Best take a familiar geographical area and going to skew it, move it, tweak it around based on a property that more truly reflects what you want to see. So in this case, you're seeing population being used as a data to skew the countries. So no longer do you see, say, Europe standing out as much as it does, but India suddenly and China become these huge mammoth blobs on the map, right? Here's another sort of example which I really like because it shows this interactively and it really gets the point across. So if you see the top, I'm just switching between different data fields and the map is slowly moving to highlight the sort of view of the world based on that data. And this is a very interesting technique. It really breaks the sort of biases that we might have which are coming in because of how a map looks like. So suddenly, just because there is a huge state doesn't mean that it have as many people, and density of people or your own data properties starts becoming much more useful, easier to reflect. And here's another technique. So in this technique, what we were doing, we were taking a geographical area that we are used to seeing and tweaking it around. The second technique, on the other hand, makes a shape for each of the geographical area, represents them in a form that we are very comfortable with, and then moves it around. So it becomes slightly more abstract. This is called the Darling's cartogram. This is an example from Mike Bostock's Protovis time. But it's super interesting because it illustrates two things. It illustrates how obesity has increased over time in USA, and the color kind of gives the density, or like how much, not the density, but the percentage of people in each state and how much obese they are. So this is going a bit on the abstract side. So suddenly we're not using the map as we see the map, but we're using an abstract representation of the map to start visualizing data. And there's another sort of very interesting piece. And if you're interested in cartograms in general, the best idea is to look at a lot of journalism websites because they deal with these sort of issues the most, where you're seeing a shape of a country, of a state, which you're very used to seeing, but you're changing the data to actually reflect the story that you're showing. So here's a square cartogram which changes the size based on how many policies are there, and it uses color to kind of identify, okay, is this the state that has said yes, is this the state that is still thinking about it, or is this the state that has said no? And here's like another interactive sort of switch between making like a traditional choropleth to making a cartogram. And I think this is a good example to highlight. So this is UK, and you can see London, which is way below, gets highlighted more prominently, and some parts of the map which are less populous are reduced in size. So this is a fun technique to try out. I would love to have conversations later on how to make these or what exactly has been a problem that you've been trying to solve with this. But there's another technique, and I'm just here to talk about different techniques so that we all have different fodders to think about the next time we're doing something. And this technique is called tile grids. So in the previous one, we were changing the shapes or the sizes of different parts of the map based on the data. In this one, we represent each and every shape in a single equally sized entity. And this becomes more interesting if your data set is something that is equally important for each state, right? So it doesn't depend on population, it definitely does not depend on geographical area, but it just depends on the number of each state. So if we suddenly start talking, for example, how much percentage of our budget goes in each state in different countries, in USA or India, you don't care whether whether the state is huge or not. You're first interested in seeing the percentage. Maybe you want to do a per capita, which kind of removes the population at all and gives you a better picture. So in cases like this, a tiled grid map becomes really interesting and becomes even more interesting if you use something called small multiples. So for folks who are very used to data visualization, small multiples is a very familiar term. Make a chart, repeat it, and change the data to show seasonality or see the change over time, right? And so tile grids, because they've suddenly become very abstract and easy to show in a very small space, make for great contenders to do small multiples. So this is a great example of showing the similar data of obesity, but now showing it in a single view instead of using, say, a timeline to move through it. So that was cartogram. Cartogram is slightly complicated to create. You can use tools which are, say, all for posting photographs on Snapchat publicly. And showing a heat map with it. So suddenly a heat map is no longer just a data visualization technique, it's also a great technique to nudge people to explore different parts of your data. And this becomes really interesting in some daily interactive use cases, one of them Snapchat. So essentially, if you're making heat maps, it's going to be great if you're going to do like a high level overview, and it's the only caveat there is to choose your colors wisely. So in this case, you can notice that the color palette goes from a light color palette to a dark color palette, even though it's still very rainbowish. And that's just something that we can, again, talk a bit more about in the OTR session if you want to talk about, or maybe catch me after the talk, on how do you pick colors well. Because colors itself, even though we think red, green and blue feel like a natural progression, have different hue and different sort of brightness and saturation that goes around. It's interesting to see how you would want to use this. And last two very examples also to talk. Isoplets, and it's a very scary name, and they have like many more variations like isochrone and isobars, etc. But they're essentially using lines to mark data as boundaries, right? And here is like a very easy to see example. So from MLR convention in Bangalore, where can I go to different parts of Bangalore over different amount of time, right? So while we're very used to seeing point-to-point data temporally, saying from place A to place B, this is the amount of time it will take, suddenly we start putting temporal or like time-related data on top of a map and start seeing, this is interesting, there's some part of an infrastructure that's really limiting people to go into one direction, and maybe that's a great example for somebody in infrastructure to understand. Or maybe it's just easier for us to understand, hey, next time we are hosting Fifth Elephant, what is the most accessible place which reaches to most people in Bangalore? So isochrones are super interesting, slightly complicated to make because they're essentially going to use a lot of data. In this case, you would want to use some sort of a direction or navigation data set that's going to tell you, okay, this to this, so this to this is going to be this much time, but it's super interesting to get the insights out of it. And I know now is going to be like a better trigger for people to slowly move out, but before that, let's quickly finish two more things. So flow maps have been one of the more commonly used map techniques back in the days, before you had interactivity, before you had all of these fancy tools that we have. And this is one of the many interesting flow maps that you can see. These become much more interesting when you have connectivity or connections in your data. This today is slightly more complex to represent, and you need to mold your data to get easily like make such maps. They're also very interesting to tell stories. So some of my favorite stories which I've seen in journalism have come out with people using flow or showing flow from one place to another to tell insight. So in this case, for example, if you can see the arrows, this shows where people or where students from each state in USA go to another state to attend public schools. And that makes this very interesting sort of conversation that none of the other sort of map visualization techniques would be able to convey so succinctly or easily. So to like wrap this up, flow maps are essentially connections. They're really useful to do storytelling and build narratives around. And last and not the least, because this is something that people love and hate, is 3D. So I'm going to just wrap this up by talking about two very interesting examples of what we would do when you have 3D stuff on a map. So this is the first example. This is Vancouver, and the government there is trying to see how is our area basically divided in different zones based on different types of usage of the building area. But it's interesting here to see the data not just in a 2D view, but also in a 3D view, because you get like a better perspective of, okay, this is actually how the city is. Most of these areas have these very small, very low height buildings, whereas that's the main downtown area, and the downtown area has been dedicatedly kind of zoned in to have these sort of types of buildings, right? So this is an interesting use case where you would want to use 3D. You want to show the real world as close to possible, and then you would want to use a concept. In this case, this is essentially a sort of choropleth, if you may. Slightly south of San Francisco, you'll notice these sort of anomalies. And these are some of the good examples or use cases where you would want to try and use 3D. In all other cases, 3D is generally a gimmick. And as many other database guys would say, before you're using 3D, think, do you really need to use 3D, right? So that's, I know this is like a very heavy load of something like a textbookish, or like, oh my god, 10 different ways to visualize data on a map, but the idea or the goal being, hey, these are the things that you could do. And before we wrap up, I just want to mention very quickly the tools that you would want to use. I am a designer, so I don't write as much code as I do, but I am Carto, which also do a lot of interesting sort of data visualization by drag drop or very seamlessly making map styles. Then there are these slightly more things, maybe things that we are more familiar with. So familiar name being D3, Mapbox as a WebGL, graphical library, Mapbox.gl. There's also Uber, the guys are outside, so you should probably chat with them. And there's DeckGL, and then there are these GIS tools. So I want to wrap up with this very interesting and like slightly tongue-in-cheek quote which says that nothing is certain in this life but death, taxes, and requests for geographic data to be put on a map. So with that, that's me, Rasagya. Thank you so much. Do we have time for questions? Cool, so we could take some questions now, or otherwise you can all come over for the OTR session where Anand, Amit and I will be hanging around as well. Anybody has any questions? Or do we all just follow the crowd?
Everybody work. We'll be back in here at 11:50, and at noon we have an OTR on financial data analysis.
check.
Hello, hello.
Hi everybody, welcome back from break. We're sort of having an extended break because, well, not exactly a break. Lochan's going to come out and give us some stretching. We spend a lot of time sitting in these conferences, so these are a chance to move our bodies in a very particular way. Thanks, Lochan.
Hello, hello, hello. Hey guys. Not gonna say a word. Can we stand, please? Have to end up saying it. Alright, how does the day feel? Are we on an incline? Are we on a decline? Are we just plateauing? Where are we? Plateau? Yeah? Yeah? Would you like to feel like this all the time? Like here all the time? Do you think it's possible to feel here all the time? Yes? No? Maybe? Yeah, because I don't feel like I'm there now. I'm just there. But it changes, I guess. Anyway, so let's start with warming up a little. I feel a little chilly here. I don't know about you. I just don't know if it's just me, but let's just warm up. Yeah. Let's start with the head again, forehead. Onto your eyes, the sockets of your eyes. Nose. Your cheeks. Your ears. Give them a nice rub. In school, I used to, obviously, like being a kid, being a naughty kid, get pulled in my ears a lot. You know that warmth you get when your ears are pulled? It's something. Yeah. But your neck? I mean, just put something into it. Just don't do this. What is this? Alright, your hands. Okay, feel it. Chest. Back. It's nice to see more people pouring in. Go down, your thighs. I can barely see anyone doing this. I've just been looking down all the time. Okay. Alright, let's start then with the head again. This time we shall do rolls. Look up and down first. Up. And down. Breathe in, up. Down. Breathe out. Breathe in, up. Down. Breathe in. Down. In. Down. In. Down. Let's go left. Breathing up. Let your chin lead. Right. Left. Breathe out. Center. Breathe in. Breathe out. Right. Center. Breathe in. Breathe out. Left. Breathe in. Center. Breathe out, right. Left, right. Now drop your ears to your shoulders, left to your left ear, your left shoulder. Right. Again, breathe down, breathe out. Right. Left. Right. Left. This time hold it in the left for a bit. Just feel that stretch. Just feel the tension here in the neck. Compression here. Don't raise your shoulders, just let your shoulders dangle. Yeah. Right. Hold it there. Back up. Okay. Hands up. Shoulders. Breathe out, elbows together. Breathe in, shoulder blades together. Breathe out, elbows together. Breathe in, shoulders together. Out, in. Out, in. Out, in. Do it a little quicker this time. Hear yourself breathing. Backwards. In, out, in, out, in, out. A little faster. Excellent. Bring your right hand over. Hold it there. Left hand over. Hold it. Left hand up. Try and pull it down from the elbow with your right hand. If you can, again, hold. And breathe as normally as you can. It's okay if you can do this, it's okay if you can do this. Just, it keeps getting better with time, so just stick to it. Okay, other side. Excellent. Okay, loosen, shake your hands up a little. Right, fingers. Okay. This way. Hold it. Feel your forearms, the tendons, the ligaments, the skin stretch, all of it. Okay. Okay. Let's get to our hips. I guess we have about a minute, so maybe 30 seconds doing this. Again, head stays steady. Feet about shoulder width apart. Don't angle your head. No. Okay, nice. The other direction. Yeah. Did you guys try the squat yesterday at all? I told you guys. You did? Come here. Come here. One. Okay, that's an improvement. Okay, I guess we're out of time. I'll see you in the afternoon.
Thanks, Luchan. So our next session is an OTR, an off-the-record session. Now there are 2 off-the-record sessions happening at the same time. In this room, where we had data visualization all morning, is not the data visualization OTR. That one's happening in room 1. So if you are here because you think the data visualization OTR is happening here, you need to switch rooms. If you are here because you are here for finance data analysis OTR, then you are absolutely in the right room. We have 2 facilitators today, Deepak Shenoy and Chandi Jain. Because this is such a complex topic. interesting talk. Thanks everybody for participating in that OTR. I think we could have gone on quite a bit longer, but we have another talk. So our next talk is also by a speaker from Mapbox, but not a designer this time. Bhargav's a software engineer. So this is going to be a little bit more machine learning style. Mapbox works with OpenStreetMaps. You guys may know OpenStreetMaps as an open source global mapping service. And they invite volunteers to make changes and updates to the map. In fact, I heard today that there are 2.5 million changes every day to this map. Well, gosh, that leaves a lot of allowance for mistakes, user error, malicious errors, that can really get people misdirected and all turned around. So how do you make sure that those errors don't compound and that you catch them? Well, that's what our talk is about. Bhargav is going to talk about how machine learning solves some of the problems of mistaken edits in OpenStreetMaps.
called ID. The others are JAWS, maps.me, etc. So basically what you do, you select a feature on the map, you get to see from the properties of the feature. What's the name? What's the address? Where is it located? And then you get to modify content, make it better, and then hit save. And as soon as it's done, it's like OpenStreet map for all the users. Map box, maps which are covered by OpenStreet map, consume latest changes from the project and kind of give it to millions of users on all the apps that I showed you little by little. All this happens in 10 minutes or less. So any area that goes on OpenStreetMap is live on all the apps in 10 minutes or less. Amazing, isn't it? The problem now is, since OpenStreetMaps kind of by default open for contribution, the quality of the data on OpenStreetMap comes from validation. Validation, the process of checking the accuracy of something. Some things that could kind of potentially go wrong is, say, a new mapper who is kind of learning how to draw a highway and then starts drawing one point after the other, and suddenly there's this quickly length of things that he gets stuck on. What do you do now? Another could be Pokemon. When Pokemon Go announced that they use OpenStreetMap in a lot of countries for spawning Pokemons, suddenly there was this frenzy on OpenStreetMap. Lots of parks started showing up everywhere. The idea is there's a park, there's a footway, chances are there are Pokemon spawning happening. So lots of Pokemon activity suddenly started happening. Artwork and graffiti, there's something kind of so beautiful, but if something is not in the real world, it should not be on OpenStreetMap. So although beautiful, they don't kind of OpenStreetMap is not the case for it. And there are cases of the rare cases of vandalism where people kind of add something that's kind of fictitious. Say a lake comes up in the middle of Manhattan from nowhere, and suddenly you see the map. Oh, what is this blue dot? Or what is this blue square in the middle of the lake? They have to be building the lake. So the idea of validation is kind of to kind of have mechanisms, workflows around to kind of protect. The additional sense of validation of OpenStreetMap has been another mapper from the community. Say I map my neighborhood, and there is some other mapper in the community who kind of looks at the changes that happen as and when they happen. Oh, the new highway got fixed, not here. That looks interesting. There's a new hotel here. Something like this. And they get to remove the properties, like what are the tags that it has, key value tags. What are the geometries? Is it the line stream? Is it the point? Is it the polygon? This has worked great for all these years. But now, like before that, I would like to talk about wisdom chart, which is kind of one of the tools that gives users the ability to kind of review things. What you need to see here is, on the left, is a list of chain sets. Chain sets are basically a good way to think about chain set is a Git commit. It has a couple of files modified, a couple of files deleted, new files added, something very similar. Some new features get created, modified, deleted. So that's a chain set. That is done by one user. So all the chain sets are listed on the left. Users get to click on one chain set, and they get to see all the details about the chain set. What features got added. In this case, there's this building in the center. The properties, there are two columns. This is the old version, which the properties before the user actually made the edit. And what the user edited was added the name of the feature. And then what happens is when things are kind of gray and stuff, users get to do a thumbs up on the top right. Let's kind of. And they say good. So when a chain set is kind of everything about a chain set is good, it gets a thumbs up. And when something is problematic or harmful or something that needs correction, it gets a thumbs up. When something is not right, what are the kind of common actions on OpenStreetMap as a project? looks a little kind of wrong to you, this is the documentation. Can you kind of improve it? That is kind of worked very nicely in most of the cases. The other is when something is really wrong and you want to fix it, you can go ahead and slowly make that edit. The other is to kind of revert the whole chain set itself, like the whole thing kind of looks really bad to me. Let's revert the whole chain set. There are cases of the users receiving blocks as well. When the user continues to do wrongful activities or is trying to kind of harm the man or something, the user also kind of receives a block. All this in the context of OpenStreetMap being kind of an open project. Okay? All this is the guys. Again, on OpenStreetMap, 2 million features kind of get touched. By features touched, I mean new buildings get created, parts got modified, temples get kind of again added to details and stuff. And more things, say, an old point of interest, etc., is deleted just as a game mechanism. This happens in 25,000 plus chain sets, which are kind of groups of changes, and 5,000 unique mappers. That's the OpenStreetMap project in this area. We at the Mapbox data team have validation as part of our kind of daily workflow, and this kind of involves monitoring changes to kind of prominent features, say the Eiffel Tower, etc. We also kind of monitor edits by the users, like what are the users kind of adding to the OpenStreetMap project. Large edits, say Lake Michigan or something that kind of touches kilometers of the map. Imports, like millions of buildings getting imported to the project in a new city or something. Also, we monitor kind of things like changes in routing and navigation. A highway that's there and suddenly it becomes a one-way. So to do this, we want to be kind of smart about what we look at. As I said, 2 million plus features is not something that we can practically look at. And we want to kind of build tools and intelligence systems around to kind of focus and narrow down on just a subset that are kind of potentially problematic that we kind of really want to spend human effort on. The first project I would like to talk about is OSM Compare. This is an open project on GitHub. Mapbox, github.com, Mapbox, and OSM Compare. The idea here is you take some knowledge of the real world and convert it into small modular functions. And then when something happens, these functions flag it. I would like to give a couple of examples. First is a very large building. We all know from the real world that buildings are some area in size generally. And when I say there is this building in JP Nagar that covers all of JP Nagar, that looks like an anomaly. It's not something that is common to happen. So this is one kind of knowledge that we have about the real world. Buildings cannot be covering the size of JP Nagar, which we translate to small functions called compare functions. And one such compare function for the building is here. What we do is, given a feature, check if that feature is a building on the last line, and then calculate what's the area of the building. And in this case, the hard-coded value is 1 square kilometer. So if the area of the building is more than a square kilometer, flag it for that building. Because that's something that we don't expect to happen in the real world. Another example is invalid highway land. Highways can be, say, a primary highway, a tertiary highway, a bus stop. But it cannot be a building. So a building is an invalid value for a highway. Similarly, we have a list of tags like T-value pairs for a highway, T being the highway, values can be motorway, highway, tertiary, etc. And then whenever a new value comes up on the OpenStreetMap project that is not part of this list, flag it first. So kind of like say, this is not valid value. What's worked in this rule-based system small, modular, so very simple to identify. In the process of writing lots of compare functions, gain lots of domain expertise about OpenStreetMap project itself. What are the different features? How are they mapped? What is the dimension? How do the properties look like? How do the geometries look like? And then lots of team members who are kind of new to programming kind of shift a lot of production code in this process because this was kind of a great way to start programming. What's what's so great is they're very intuition based. They kind of require constant maintenance. When you say 1 square kilometer is a large one, should it be 5 square kilometers? Should it be half a square kilometer? How do you decide? They're kind of very intuition based and not very data driven. And then there are infinite number of possibilities of mapping. How things can go wrong or go right. Because it is in a way just a generic key value. This brings me to our machine learning experiments to kind of try to find a solution to such a validation problem using techniques of machine learning. I kind of really like this talk by Josh Mills, where he kind of says there are two kinds of data scientists. One in the lab, the other in the factory. I'm definitely in fact a data scientist, software engineer, wrong place in the wrong time, stay all. Just that this machine learning project comes up and yeah, let's try to learn as much machine learning as required to solve this problem. Machine learning, the field of study that gives computers the ability to learn without being explicitly programmed. I kind of really like this definition for the simplicity of it. With compare functions I showed you previously, we were explicitly programmed. This is a big build. This is an value map. And now can machine learning, can the machine learn given lots of data from the map? That this looks good, this looks potentially hard. The data that it has is all that is kind of blocked, geometries, the properties, the labels, the editor that was used, the comment steps kind of left by the user. So this is the kind of ultimate question for machine learning based solution. That given a feature, can we kind of predict, can we build a model that predicts whether that feature comes up or not? Gopher is one such kind of experiment that we are kind of working on for the last couple of months. It's a machine learning library built with both Python and JavaScript, open architecture, GitHub.com, AppBox, and Gopher. It's kind of experimental and so basically there are two architectures here, one the offline and the other is the online architecture. In the offline architecture we prepare the datasets, the training, testing, validation datasets. Jupyter notebooks are kind of easily used as part of the workflow to kind of use these datasets, train the model, evaluate it, and kind of ultimately then serialize, dump the models for later use in production. And in the online architecture, OpenStreetMap as a project releases weekly changes. Like whatever happened in the last bit gets released in one block file. And that is what we kind of listen to. These are the changes that happened in the last night, converted to JSON, which is kind of makes it easier to kind of process and write scripts. And then extract whatever attributes that the models kind of need. Use the serialized model and get back predictions. Whether those things kind of are observed. The data sets, this flows, this is a work that AppBox has been doing for close to 1 year now. And this has resulted in this golden amount of 90,000 plus labeled data sets. And this is totally unique in the OpenStreetMap project world. This is taken close to a year now. But this is a good UX structure. Here, we don't want to tell you whether something is good or bad. What we want to see is give all highways that are present in the world, both geographies and properties. And it kind of looks at all these highways and says, among all these, 99% of these look very similar. This 1% looks very different. It's not saying it's wrong, it's saying it's different. So, with unsupervised learning, that's something that we're taking right. So, the current state of Docker is the initial version of it is kind of deployed on production right now. What it's doing is, as and when new highways are created in the OpenStreetMap project, it reviews it for both properties and geographies, extracts the features, sends it to the training model, extracts predictions from the model, what it think, whether it's kind of a good or a bad from what kind of has been trained upon, and then dumps kind of the result on wisdom chart, which is kind of a review tool for users to do that. The label that we kind of uses flag developer. This dataset has been kind of flag developer for review. There is also an experimental tool that, given the chain set ID, it lists the features that were kind of used for the right model for kind of training classification. Today, we talk about some of the insights that we kind of had in this kind of journey building Docker. The first, something very common, model performance versus training size. Like we all know, the more the data we had, the better the performance of the model is. So it's kind of nice to see this trend generally going upwards, and you also see it's not flat, so there is kind of an opportunity to add more data and make that better, take a better model in terms of numbers. Modern hyperparameter theory, say for a decision tree, how deep should be the decision tree, how many deep flows should we have. Okay. These are hyperparameters, and tuning these hyperparameters is kind of a real. We saw kind of 10+% performance improvement, 10+% when we kind of tune these like model hyperparameters. On the left is before the parameters were tuned, and on the right what kind of comes up when you start doing this parameter. Constant part of the workflow was coefficient matrix. Basically, we want numbers of the diagonal to be as high as possible, and numbers of the anti-diagonal to be kind of as low as possible. And what the workflow is as and when new models are kind of trained, each model we take a couple of samples out and kind of review what is the model learning, what is the model not learning. And this has to be kind of very effective. Something very common in the NLP space is back of words. Which kind of works great for free-form text. But with OpenStreetMap and other structured data, there is no kind of free-form text as such to use. So you get key value text. So you modify the bag of tag words concept to bag of tags. Basically, each tag is kind of one word. And this example is where there is this feature. The version 3 of the feature doesn't have a name, so it has a 0 name. And then the version 4 gets a name, has kind of one after encoding the answer for the language. We've seen kind of how the samples kind of affect the model performance. This is one particular use case where there were 5 features that were very similar, and one of it was labeled kind of bad, and the other 4 were labeled good. And for some reason, the model was always saying these 4 are bad too. And that was kind of interesting, right? These were manually labeled as thumbs up, but the model was saying thumbs up. But because there was one sample that was kind of bad, the model was trying to push for the badness of that particular feature. Now, everything is kind of great. We've kind of learning a lot of things in the process. So the first is there are a variety of features on OpenStreetMap. There are temples, highways, parks, residential layouts, etc. Each feature has properties of its own. Like for a temple to have opening hours, where is it located, what's the address, etc. A highway can have what's the speed limit, is it a one-way, what are the hardware rate where we can have a generic classifier that can classify any feature and whether that feature is kind of a good feature or something wrong. There will be like model performance versus attributes. Like you measure the performance of the model as and when you add more attributes to the model. And we've kind of seen some other cases that we don't understand where the model performance suddenly dips and kind of don't always know why it's happening that way. So we will kind of the biggest learning for me personally the last 3 months working on this project actively from a place where I did not know what is machine learning to something in production. Yeah, it's an experiment in alpha version, but still. So that's machine learning is hard, but it's kind of possible. So in this way, I would like to kind of encourage anybody here who has machine learning projects of their own and trying to use these techniques to kind of take a shot to real life. Some of the resources that have been helpful for me is a couple of books, Hasgeek, Coursera. This free book, Python Data Science Handbook by J. That's on GitHub. The second, the documentation is kind of amazing. Happy to answer any questions. Thank you.
If you have a question, raise your hand and we'll bring a mic over.
Hello. So I work for a company called Here, which also makes maps, and I do a lot of projects like the one you mentioned internally. So I mean, like we also have been struggling with a lot of machine learning models for validation. We need really high accuracy because our maps are primarily used for navigation. So error rates need to be like 0.1% or lower. Now, the problem is that when you talk about unsupervised learning, we also actually had hope that, looking at our, there's a plethora of data we have in our stores, and we intended to find a lot of some anomalies which can guide us, but it was really hard. So I would like to know, like, so you actually mentioned, classic confusion metrics and all that, but like, where can I get some resource about the unsupervised or anomaly detection methods you used, or what kind of features were there, things like that. In our case, just to give an example, just for the signpost, we have 187 different types of signposts. So you can imagine like the kind of data we had. We expected that we'd find some signals, but at least so far we have not. So
basically, Cover is an open project. A lot of the feature engineering, model training are part of Jupyter notebooks. So you can find the repository from GitHub.com and box and Cover. Basically, unsupervised learning, we're using anomaly detection as one of the approaches to kind of try to understand problems.
Hi, great talk. Thanks a lot for the talk. My question is, how do you merge supervised and unsupervised learning in particular in your domain, right? Because suppose you find an anomaly using unsupervised learning, then do you apply supervised learning on that, or is it like they're just separate system and you're trying to figure out which one works best and which one doesn't?
I think there are kind of potential use cases for both. We've not thought about merging the two yet. But one advantage with supervised learning is we know what we are expecting. But there we are kind of limited to what we have already known. There are some new ways of training the map that we kind of don't know about. And that is something we want to kind of explore with supervised learning. It's not practically possible to kind of look at all the ways that the map could behave and stuff. So we try to go the other way around and see what's different, and then try to see whether that difference is breaking the map.
Hi, Ravi Mutnuru from Capital Flow.
Learning project or an open learning project. So that's something we're trying to get. The APIs are free, and we have a hosted version of Cover that the community can kind of consume. And also the resources of how we can be the model, what are the features, that's also a part of the repository. including the latest models. The data sets are also kind of unexplained. So if somebody are okay to be part of the company, so that the project has more kind of benefits from these technologies.
Hey, thank you for the talk. My name is Shubham, I'm from Microsoft. So it's like one of the slides you pointed out like insights versus the model which we built, the machine learning. So I want to know about like sometimes we follow insights, but the model which we built based on the insights does not give us the best results. So for the solving one problem we have two approaches. Someone say that these features would work out, someone say these features would work. So how do you generally judge on the basis of insights, like, or where you do get the decision on that which insights would give the better result? Is it just the experience based, or it also has something algorithm on top of the insights which actually take the decision which insights you should go with? This because insights are always not always the best way to go. In my practical case only, the insights were not giving the better results, so we trained two models, then so which were. So what is the approach in this case? Is we should always go with the models or experience based, or I mean just
Domain expertise has been very critical. The domain expertise kind of building rule-based systems has been kind of very important and kind of important for building these machine learning models. So I would say something like supervised learning and stuff, you definitely need domain expertise and insights. But what we want is supervisors can be like take a data sets approach where the kind of findings are different and then see whether that difference is taken the map. So there's a lot of like iterating this kind of a process where you try something and it does not try something else. Lots of iteration.
Hi. You mentioned about the anomaly detection, that are you using any time series component, like which models you use, like there are IMA models and things like that. So which one do you use? And for the model selection, do you use any AutoML kind of feature? How do you decide that the best model? Are you using the AutoML or it is a manual process?
No time series component as such. We're using something called isolation forest. And then on AutoML, we will not do time series. It's kind of a manual process.
I have a small question. Can we use unsupervised information for supervised learning?
I think potentially yes. Because with supervised learning, we are always kind of limited by what we already know. You kind of want to know what are the other ways that this could go wrong. So ideally, sometime in the future, we want to take the learnings from unsupervised learning and feed it back to supervised learning. And kind of improve supervised learning. So that's why we're kind of investing in both at this kind of very nascent state of learning.
You can definitely tell it's the second day of the conference because everybody's bolted off to lunch. But we have time for one more question. And then the rest of you can bolt off to lunch and the line should be a little shorter.
Thanks for the talk. My name is Ayush. So the question is that do you only review the ones which are flagged by the Gabbar, because then you need to believe your algorithm that it's pretty good when it is saying good. And what are the algorithms that you are using? Some particular ones, if you name a few of them.
So basically, the world class currently has been rule-based. Machine learning-based system cover is still very experimental. So what's kind of working currently is the rule-based system that I showed, where you build this value. We have a problem close to 70 plus these rule-based system problems and flag a subset of these 2 billion features for annual review, close to less than 500 every day. Couple of models that I can talk about is very random forest decision trees on supervised learning side. Now unsupervised isolation forest is something that we use.
More to do with like which I also faced in my company is that if you have labels which are not flagged, How do you know that those are correct? So it's like if they are flagged to be wrong, you know that they are wrong. But if they are not flagged, you cannot assume that they are not wrong. So yeah, so this is a problem, and I would say that you should explore things like one class classification and stuff like that. So.
Exactly. This is the economic we not be able to be in a position to identify or know all the problematic things and say got 50%.
Have you tried using like an artificially created or pseudo data set to test your models? Maybe that's one way of refining and tuning your model. And if so, in this map case, how difficult or easy is it to generate fake data points, features?
These are testing say I have not generated fake data. So let me talk to you about generate fake data is not be a challenge. Features generating what properties
Thank you all so much for your attention. Hi, everybody. As you trickle back in from lunch, I have a few announcements. What a surprise! Can anyone anticipate what my first announcement might be? Hey, yeah, it's about feedback forms. So you'll find some new ones on your chair. These are the afternoon and evening feedback forms. So the ones that you used this morning to rate all those amazing talks, or maybe all those really crappy talks, they need to go in here. And now you get to fill in the other sheet. We do thank you for doing this. I know it's kind of a hassle, but it really does help us out. I'd also like to make a note about a problem with our schedule. We put a talk in the wrong room. At 4:25, there's an OTR that's marked as room 1. But if you go to room 1, nobody's going to be there except the other people who read the schedule, because the OTR is actually in the banquet hall. So if you're thinking about going to the Learning Data Science OTR, please go to the banquet hall at 4:25. We also have something that's not on the schedule at all. Between 4 and 5, there is a discussion on diversity in data science, and that will be held in the food court, actually outside in the pretty tents of the food court. So if you are interested in talking about how to get more women involved, or any other sort of diversity, I suppose, please go to the food court at 4 o'clock. Speaking of diversity, we have a childcare facility here. I don't know, how many people brought their kids today? I know we had scheduled about 12 children in the childcare facility. Intuit is sponsoring that, and we thank them very much for their sponsorship. I think that might be all the announcements. Does anybody have an announcement out there that they'd like to share? Oh, wait, I do have one more. If you have not yet submitted your flash talk, you still have time. Flash talks are tonight from 5:40 in the banquet hall. And you are invited to submit a 5-minute talk. No pitches, no please hire me's, but anything else is fair game. If you want to submit a flash talk, please see Harshal over there. Give him your name, your phone number, and the name of your talk. Over there, raising his hand. All right, well, I guess that's it for announcements, so allow me to introduce the next speaker. Our next talk is another machine learning talk, and it's about teaching machines to recognize images. So if you go to an e-commerce site and you're looking at 2 different products, you know that they are 2 different products. They're different sizes, they're different colors, but machines aren't as good as humans at telling the difference between things. So Govind, who is the co-founder of Semantics 3, not our first speaker from Semantics 3 during this conference, has spent a lot of time working on this problem, and he's going to tell you about some of the lessons he's learned in trying to get machines to differentiate between photos.
Welcome back to lunch, everybody. My name is Govind, and I'm going to be talking to you today about 5 lessons I've learned tackling product matching for e-commerce. I hope this is interesting because I hope all of you might have an e-commerce background, so hopefully we learn something interesting today. Like The other benefit of having these algorithms aside from making our data better quality is we also have these AI APIs, machine learning as a service APIs, if you will, where we offer these algorithms as a standalone service. And that's how this has a secondary benefit on both basis. But that's that. Here we're going to be focusing on a fourth algorithm that we work on, called product matching. Now, product matching is a very simple concept. Two different products which represent the same thing on two different websites. If you look into these, as a human being, you can tell that they refer to exactly the same entity. But they have different images, different text, different descriptions. And just to be clear, we're not just talking about images, we're talking about all the other components to it. So there is a natural language component to it, there's a computer vision component to it, there's an ontology taxonomy component to it, so it makes for an interesting problem. It also makes for a challenging problem for a few reasons. I'm going to show you a few examples where we've been tripped up by this problem in the past. We have to deal with things like variations. So the iPhone can be a little bit black and jet black, which as an Android user I didn't know until quite recently, but generally these are distinctions that are algorithms that are making excuses for. So we've got to be able to detect differences like this. We've got to be able to detect differences in, again, I don't know if this is a high resolution, but if you look at the embossing folder, one has a heart shape embossing, one has a square shape embossing. So again, if you're doing detection, you've got to figure out things like this. You've got to do a lot of branding works. Yours something has a warming lozenge and a liquid signal lozenge. If you read the fine print, the warming lozenge has a liquid signal. So as a data scientist, I wonder why these works exist, but again, that's not for us to debate with the companies. We've got to deal with these challenges. So that makes for a rather interesting challenge. Why don't I tell you about all of these works of product matching? Because that's going to be at the center of my talk today. My talk today is structured as 5 stories. I think stories are a fun way to really wake people up after lunch. And these 5 stories are going to be all themed around my, and well, more broadly, my company's journey towards making an attempt to solve this problem of product matching. And each of these stories is going to follow a very simple structure. I'm going to be talking about a specific sub-problem or a specific goal that we try to solve in the context of product matching. A problem that we ran into as we tried to solve this goal. The cause of the problem as we later determined to be the case. And finally, the lesson that we will go into all of this. You'll get a sense of the structure as I go through the first story. But I just want to point out, my goal for this talk today is not so much to give you a guidebook on how to solve product matching. It's not to toot our horn and say here are the great things we've done. I felt like it made for an interesting talk because, well, for starters, it's fun to listen to. But I also think it highlights some of the challenges that we ourselves have gone through and evolved through the years. We've been in business for nearly 6 years right now, and we've been solving this problem in different capacities over the years. So different tools have emerged, different insights have come through. So as a company itself and as an individual itself, I've started seeing this problem in different ways. So hopefully you can relate to some of the lessons and some of the thought processes I went through and maybe take it forward in your day-to-day work. So without making things further, let's get started with story number 1. Okay? So the first thing we wanted to do was very straightforward. We wanted to build a good data set for training and evaluation. We needed a way to measure things. We needed a way to train our algorithms. At first, we started to construct it as a binary supervised classification problem, which means we needed 2 types of data. We need matches or ones. And this we got manually curated by humans because we couldn't find data set out there that already exists for us. It was really difficult to find heuristics that would infer these kind of things. So we went ahead and did it ourselves, slightly expensive process, not ideal for a startup, but worth doing for what we wanted to do. For the non-matches though, which is for finding examples of pairs of products that don't match, we do a semi-automated heuristic-based approach. Finding products that don't match is actually really easy. I give you an apple and I say, tell me a product that isn't an apple. You can give me anything. You could give me this projector, you could give me any of the phones in your hands, and you could verify these things. These are 2 different distinct entities. But the challenge here is not finding different non-matches. The challenge here is finding similar products that are almost the same but not quite the same to make it difficult for algorithms. Coupled with that, which made it a difficult challenge for humans to do, it's difficult for humans to find something right, which is almost there but not quite there, and with the fact that as a startup we wanted to save money where possible, we took a simple heuristic-based approach. So we took 2 products. We basically looked at products from top sites, and we picked out the 2 random URLs from to empathize with that part. So hopefully these are some ways in which you can sort of think through the process in which you might have done things wrong. And be aware of this, because at the end of the day, these are not fundamentally earth-shattering observations, but they are things that you bring to the table and save you 2-3 weeks of brainstorming. And to give you an example of why this is not, this is an example that happens more often than you think. I came across this paper recently, automated inference on criminality using face images, where a bunch of researchers they set out a very interesting objective, which is they tried to look at profile photos of people, photos of human faces, and try to detect, looking at someone's face, looking at your face, and I tell whether you're a criminal or not, with no other signals, just how you look. And with analytics, they were able to get 90% accuracy, which was super surprising because it goes against our sensibilities that human beings are defined by how they look. More so because they came up with these interesting observations. The angle of your nose to your mouth is 90.6%. You're likely to be a criminal, more likely to be a criminal than someone else. Very minority information that goes wrong. And also, I mean, it gives you like a statement. I mean, papers like this give a linear objectivity because it's data, it's a machine learning model. Never mind that it's morally incorrect, it's factual, so we cannot dispute it, right? Turns out people didn't tear down, and these folks made very similar mistakes to what we did. And then really realized that after they published the paper. So some folks who did it said, no, we try to build a good negative data set. They pulled up negative examples of photos of people from all professions, doctors, lawyers, and by virtue of that, they had a huge skew of people who wear collared shirts for their profile photos, and that's what the model picked up. We tried to get a good example of people who were across all age spectrums, and not old people, all the criminals that are pretty young in the data set that they generated. So again, it picked up on that bias. So the point I'm trying to make here is these things don't just occur when they're very apparent, as was in my case. They happen incidentally. As a data scientist, these are the things you want to watch out for, not just to optimize your business metrics, but sometimes just to not make the world a worse place. So that's an interesting lesson that we learned, and something that we take forward today. That was story number one. Story number two, right? Like I said at the start, we have a whole bunch of signals from we have text, we have images, we have identifiers, we have HTML, a whole bunch of these signals that we work with. So first up, we decided to build a text model. But with the text model, the problem was this, right? Again, our model did all right. We landed getting about 85%. But when we actually looked at the data, we found that there was a huge skew. Our model did really well for some categories, not so well for another set of categories. And our next challenge was to figure out, all right, this seems to be an interesting observation. What can we take off? Turns out the problem here was this, right? So if I ask all of you to find the odd numbers, who of these refer to the same height? What have these done? Could anybody shout out which one of these isn't the same? Oh, okay, so very appreciated audience, and I had trouble with this because for me, I didn't know enough about the US, so for me, Arizona, Arkansas, both of them for me AR, there's absolutely no sort of underlying rule here. I need to assume the smart person, but if I don't know this precise fact, as a lot of people ostensibly do, which is interesting to me. But I didn't know this fact, and neither did my model, because I hadn't provided my model with a specific fact. And here I was trying to say, can I build a better network? And can we learn better logic to be able to solve this problem? And that was sort of the second takeaway, which is being able to sift out knowledge-based tasks from logic-based tasks. I think in the rush for deep learning solution to everything, machine learning solution to everything, we sometimes forget that most of our decisions and a lot of problems require knowledge and logic. And if you don't do the hard work, especially when you're building your data set, you don't do the hard work of feeding your model with sufficient knowledge, you can trip up on this and then start wondering why your model is not learning what you want to learn. And the way in which I think about this at least is I ask myself this question, right? Never mind a neural network, a human with no prior knowledge, educated on nothing but a private training data set, solve the problem. And say you woke up tomorrow and lost all your memory, all your knowledge, but you're still a super smart person. If you would just learn from the training data set, could you answer this question? Could you as a human being answer this question? And the answer to that is no. You immediately know that your answer, your way forward, in terms of pushing your precision up, is not the next bit search. It's other things that you need to be looking at. The those signals, which is kind of crazy, but it makes sense because if you think about all of them speaking the same language, the same unique language, then you understand how these shared representations are actually useful, which I thought was kind of crazy, and we took it forward and added to our whole approach and helped us overcome the problem that I mentioned previously. So the lesson I learned from this is, I mean, these are the things you want to think about when you have a multimodal model. In our case, it was kind of obvious because it was a small, I mean, the problem was kind of obvious, but I think sometimes, and even now when we see multiple signals at play, sometimes we realize that, you know what, if only we take additional measures, we could push it beyond. You could just, I mean, the approach that we took could still have yielded a result that's more than just a delta improvement, but there is potential, there are ways in which we push it even further beyond. The DOS is the sort of thing that requires a significant amount of correlation between signals. That's an interesting thing that I learned. The other thing I learned is, we're trying to figure out how this problem would work. At first, we were thinking about, should we pre-train our weights differently? Should we do a different kind of grid search? Are we using the wrong application functions? Why is the model not learning the things that we wanted to learn? And that's when I realized there are ways and there are tools beyond just grid search, or beyond just changing the parameters of your model. Sometimes the tools that you can do is change the objective of the model, which in this case was converting it from a supervised problem to an unsupervised problem, and back to a supervised problem. So sometimes the trick is to change the objective of your function, as opposed to the things that we're usually used to doing, which is adding a better layer and changing the application functions, changing all the parameters of the model. Sometimes it's just a fundamentally different approach to help you solve your technique. So I found that to be quite intriguing, and often, I mean, I try to think about how I can sort of take things from a very different perspective and how that might help. So that was quite quickly. That was a small jump in terms of complexity level. So we have a 4. So next up, right, like I said, we've been working on this problem. The chronology of this is quite spread out. I hope that the gaps aren't very, it was a problem in terms of your understanding of how all these stories came one after the other. But the next problem we had was, in the early days, and my colleague who spoke yesterday talked about how a good way to start or approach towards the problem you have is to start with simple heuristics, and then maybe try complex heuristics, but ideally not. We got into the path in the early days of bootstrap business, do whatever you can to get things going. Started off with a simple heuristic. One of our first customer who didn't have high demands made the heuristic more complex. Before we knew it, we done this elaborate piece of work to build these complex heuristics that were all handcrafted. So it came time when we actually had a bit of resources to step aside and say, it's okay, we're going to get results in 6 months. We can try a different approach. When we actually had the machine learning model in hand, the decision we had to make is, shall we replace our heuristic-based model with our machine learning-based model? And of course, the ideal thing, the obvious thing you do here is just swap it over. Then the rational folks who are people from other teams came about and said, do we really need to do this? How good is it really? Can you prove it to us? I don't care what approach you're using. Show me how good it is. So they ran some benchmark tests. Well, we asked us, we ran some benchmark tests. But what was surprising was that for some topics about data, think of it as some categories, some very specific niches in our data set. The simplistic heuristic-based approach actually worked better, which is kind of crazy, right? I mean, in my head, it was like Googling this Ferrari with a 1,800 or something on the side. You'd expect the Ferrari to win 100 of 100 races, but the fact that it loses 2 races makes you sit up and wonder what's wrong. I mean, there has to be something wrong. Yeah, so the cause turned out to be this, right? And there are several reasons. I mean, sometimes I think data was not rich enough in certain categories, so our model was able to learn as well as it would have. So we didn't help the network out there. In some cases, our models hadn't been publicly tuned. This was the time when, our grid searches were taking, our experiments were taking us at most 0.1% for every 1 or 2 weeks. We were getting a
If you have a question, please raise your hand. We'd like to ask you to stand while you're giving your question. We've had some comments from the live stream that they can't tell who's talking. We have a hand raised here in the middle auditorium aisle. Can a runner please take a mic over there?
So when you are using handcrafted features, very possible. Can you hear me?
Yeah.
So when you are using handcrafted features, we're using autoencoder after that, or just like added handcrafted features to the final layer.
That's a good question. So it wasn't so difficult for me. It's a really good question. I'm sure if we tried the autoencoders on the other systems as well, it was very, very simple systems, right? So finally, so then the amount of mechanics was very similar. So we literally even need to import it to a vector space. There's no requirement to do like image to vector or text to text or layer. We could just feed it to our final layer because they were pretty much like single neuron activation.
So sometimes we actually, whatever you use for embedding, other than that there is a lot of other metadata. So to embed those things, probably this what you have done for handcrafted features and autoencoder that might. So when you have a lot of other metadata which you didn't use in embedding, you can use this autoencoder. Yes.
Yeah, absolutely. Those are the there's no need to
Another question? Way back in the back, the farthest back corner. Yeah. No, it's working now. I just heard it.
Not a question per se, just like a discussion. So, yeah, I recently read a paper, One Model to Learn Them All, published by Google. The question is like, the discussion is related to multimodal learning, which you discussed in your slides. So, what they did was, like, they had one model, not a different like approach, like a middle, like not using autoencoders for multimodal learning, but a single model for learning the different like speech recognition or image recognition, a single model for this. So have you like done any research on this or read about that? Yeah. So what they did was they had one like AlexNet in the same model. They had the like speech recognition pre-trained model in the same like model for end-to-end recognition for multimodal learning. So the paper, the name of the paper was One Model to Learn Them All.
There's a question just down here.
So most of the time with the deep learning, what happens is it's kind of a black box. You don't really know what the model has learned. You said that you could find out issues why it learned something, right? Is there any work or mechanism for you to understand what the model has learned so that you can pick out these things?
Yeah, I mean, that's what we have to talk about, how we actually found out the causes behind these problems. I mean, different ways, right? The easiest thing, of course, is something goes wrong. And the first thing to look at is that the example is different. You ask a system, they're not encoded in the right way. I mean, we made a lot of mistakes that were very obvious to us as soon as we saw the data. Okay, so I like to think of it as layers. First look at data and say, space of data, and I can tell the difference. You look at your pre-processing. Sometimes you're doing some fancy pre-processing, but it turned out all your signals
I think we have time for one more question. I saw a hand way over there waving a while ago, so how about you, and then we're going to cap this off.
Hi Govind, Nitesh here from the cluster team. I would like to ask you, how do you go about collating multiple representations of the same attribute? Like let's say dimension can be expressed as length into breadth into height or whatever. So when you crawl data from multiple sites, the same attribute might be represented in different ways. How do you go about collating it? Or even like if you say in multiple sites, the attribute name might be the same, but the way it's represented might be different.
Right. So I don't think my slides are up there. That's so what I talked about is this product matching. We use something called feature enhancement, feature engineer. That's again, I'm not his spoke yesterday. You might want to talk to him. He works on that topic, but it's not an easy problem. You use statistical techniques. Sometimes you want to use linear, chain entry recognition order to detect whether those signals are very similar. Sometimes you log out and in do product matching. You find out that two products are exactly the same, but both their representations came out differently. Then there's something we had there. You can do something interesting where you can run that feature through a embedding space and do like in-scene visualization and see which ones are close together in the embedding space. Not very interesting things you can do. Sometimes it's just down singular human duration for the living developments. So there's a lot of answers to that. I think there are interesting approaches. There are quick win approaches which are not walking into it. Yeah, so we can talk about that later.
Thank you, Govind. That was a really interesting talk. I had no idea that machine learning would let things cheat so easily.
Thank you.
Facilitators set up for our OTR. I'd like you all to stand up, please.